Today we'll discuss HDFS write flow. HDFS write flow and HDFS read flow. HDFS read flow. HDFS write flow and HDFS read flow. Let's see diagrammatically HDFS write flow. HDFS write flow. We have master mission name node and we have multiple slave missions. Okay, we have this cluster. We are discussing these concepts. Last 7 days we discussed all these: big data introduction, Hadoop introduction, Hadoop architecture, Hadoop demands, HDFS, what is HDFS file system, what is HDFS block, what is replication, replication factor, over replication, under replication, heartbeat mechanism. Last Saturday, Sunday we discussed Hadoop installation concepts. Okay, today we are discussing HDFS write flow and HDFS read flow. Okay, so this is my Hadoop cluster. In this Hadoop cluster, I have a 5 slave missions and one master mission. Yep. Here user wants to write a file. Client wants to write file into HDFS file system. So we have file 1. User wants to write file 1. So this file size is 300 MB. Assume file size is 300 MB. 300 MB. File name is file 1. Client wants to write file into HDFS file system. So this is my client mission. So this is master name node, and these are data node missions. So we have different data node missions. So we have 5 data node missions, one master mission. So this is slaves. So these are slaves. This is master mission. So first client sends request to master mission. Client send request to master mission. Here master mission prepares metadata. So it prepares based on block size. It will read block size 128 MB, and replication factor is 3. By default, replication factor is 3. Block size is 128 MB. Based on this information, it will prepare metadata. So in this metadata, it prepares like file 1 and block 1, data nodes list 1, 3, 5, file 1, block 2, 2, 4, 5, and file 1, block 3, 3, 4, 5. It prepares metadata. So this metadata contain contain mapping between file to block and block to data nodes list. Data nodes. It contains mapping between file to block and block to data nodes list. Data nodes list. This block is splitted based on what? So file size I said 300 MB, right? 300 MB. 300 MB by 128 MB. 128 MB. So block 1 with 128 MB, block 2 with 128 MB, block 3, this is block 2, block 3 with 40, 44, right? 44 MB. So we have 3 blocks. It prepared this metadata, then it returns this metadata information back to client. Pardon? Which one? No file, only single file. Single file has 300 MB. This single file divided into 3 blocks. So this is the mapping of 3 files. One file with 3 blocks. Okay. It prepares this metadata and sends this metadata back to client. It prepares this metadata and sends this metadata back to client. Once a client gets this metadata, client performs HDFS write flow. Client performs what? HDFS write flow. HDFS write flow. Write flow. HDFS write flow. So while writing here we have two. One is data queue, and another one is acknowledgement queue. Data queue and acknowledgement queue. In HDFS write flow, we have data queue and acknowledgement queue. Acknowledgement queue. So each block placed into both places. First block 1 and block 1 data. So block 1 contain multiple packets, right? Data divided into multiple packets in network. So this is data. So same data is available in acknowledgement queue. Same data is available in acknowledgement queue. Then it will first, this is block 1, right? Block 1 is going to store in data node 1, data node 3, data node 5, right? It will prepare, this is data node 1. It will prepare in this way. One pipeline. So 1, 5 and 3, right? 3. It will prepare one pipeline. So this is called pipeline. For block 1, it prepares pipeline. Then client tries to place first sorted order data node. So it will try to write data into this one. It will try to write block 1 into data node 1. Okay. So it will copy packets into this data node 1 block. It will tries to copy all the packets into this data node. If one packet is successfully writes, then here it will mark that packet. So it will, if all packets are successfully marked, then it removes data queue and acknowledgement queue packets. If any packet is lost, then it will reload that packet from acknowledgement queue to here. Then again it will try to load into this block. So it will write a block 1 into data node 1, and automatically remaining in this pipeline, automatically this block is stores into in this mission. Client is responsible to write first block in first data node. Then in this pipeline, automatically this block is going to travel and stores into other data node missions. Replication is automatically happen. So this is called write flow. Okay, copy this one. No. It stores block into data queue and writes. There is no other blocks placed, right? So only one block is going to write first. Next, it going to write second block. After completing block 1, it will write into second block. Yep. Here, one of our friend asked when acknowledgement queue happen. See, if block is divided into multiple packets, these packets are travel and stores into data node. One packet successfully writes, it mark that packet success, tick mark. So if all packets successfully marked here, then client understand that block 1 successfully writes. If any block is not marked, it means that block is corrupted, maybe not saved in, failed in network. Then that packet restored from acknowledgement queue to data queue, then again from data queue to data node. If it is successfully writes, then it will mark that packet success. It will load. It will. Both acknowledgement and data node queues are presented in Hadoop cluster. Hadoop will take care to move this packet to here. Acknowledgement queue. Yep. Yep. I said once block 1 is client is responsible to write block 1 in first mission. Then automatically this block is replicated in other missions in pipeline. So for every block, a separate pipeline is created. For every block, a separate pipeline is created. Okay. Next, let's see HDFS, HDFS read flow. HDFS read flow is simple. HDFS read flow is simple. We have name node and we have multiple slave machines. So we have multiple slave machines. So this is our cluster. This is data node 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. So these are data nodes, and this is name node, name node. So this name node has metadata. So metadata like file 1, block 1, 1, 3, 5, file 1, block 2, 2, 4, 6, file 1, block 3, 3, 4, 6. Assume this is the block. Let me show blocks here. Create block 1, 1, 3, 5, right? So this is block 1. block 1 and block 1. Next block 2, block 2 and block 2. So this is block 2 and block 2, block 2. Next block 3, 3, 4 and 6, right? So block 3, block 3 and block 3 and block 3. So this one is 4, data node 4. So this is my data. Client wants to read file 1. Client wants to read file 1. So this is my client mission. So client wants to read file 1. So client sends request to name node for blocks information of file 1. Client sends request to name node for block information. Client sends request to block information of file 1. Block information. Then name node finds block information. Name node finds block information from metadata of file 1 and returns block information to client. Returns blocks information. So this name node returns blocks information. Returns blocks information. Blocks information of file 1 in sorted order. Sorted in the sense client 1 nearest to data node 1, 3 and 5 for block 1. For block 2, so 2, 4, 6 is nearest one. For block 3, 3, 4, 6 is nearest one. So this is sorted order. It returns blocks with the sorted order to client. So first client, then client applies HDFS read flow. HDFS read flow. In this read flow, first client reads block 1 from data node 1. Client request data node 1 to return block 1. For block 2, it will client request to data node 2. Block 3, client request to data node 3. So these three, this is responsible to return block 1. This is responsible to return block 2. This is responsible to return block 3. So these three missions parallelly process your request and returns result back to client. So HDFS read flow is very simple. Client first sends a request to name node for blocks information. Then name node finds block information from metadata and returns that information back to client. Client based on this sorted order, first client request data node 1 for block 1, data node 2 for block 2, data node 3 for block 3. So client system in the sense, client system means, see, you are executing HDFS command. HDFS command. In which mission you execute this HDFS command, then that mission is called client mission. In which mission you run MapReduce application, then that mission is called client mission. In which mission we run pick command, this is called client mission. In which mission we execute Hadoop query, that mission is called client mission. Okay, so these are the technologies is used to read this one, right? And Spark program. In which mission you execute Spark program to read This file is called client mission. Okay. Yep. Yep. No, there is no acknowledgement concept here. While writing only we need confirmation, right? Reading we have, if this one is failed, we have block in other missions, right? Yep, we rectify and we recover. Yep, what is mean by near mission? See, in cluster, these missions located in different places are same location. So I explained in Hadoop architecture, I think you remember or not, we create a data center. In data center we create multiple racks, right? So every data center is one geographical location. Assume this data node 1 is in Hyderabad, this is in Chennai, this is in Bangalore, this is in Mumbai, Pune, Delhi. So client is from Hyderabad. So for client, which missions are nearest? Hyderabad, Chennai and Bangalore. So first sorted order is 1 for block 1 1. For block 2, next nearest mission for client is Chennai. For block 3, next nearest mission is Bangalore. So in this way it will prepare sorted order. Okay. I said one more important point, proximity algorithm. I think you are not reading or you are not following previous classes. In previous class, I explained proximity algorithm. In proximity algorithm, I said we define data center information and we define rack information, bandwidth of each mission. So this maybe has 1 Gbps, this maybe has 10 Gbps. In this case, it will come first in sorted order. Yep, yep. Depends upon the latency, it prepares this sorted order. Metadata contain only mapping information. There is no data information. Data, actual data is presented in data nodes. This is just mapping information. But if you lost this metadata, we cannot access this data. Even though data is available in cluster, we cannot access. We don't know what is this block without knowing metadata. That's why metadata is very, very important. Administrator takes backup of this metadata. If question, I don't know. Question mark means how can I know? What is your question, Kiran? Karne ka na? Okay, so that's it for read flow. Next, we'll discuss HDFS commands. HDFS commands. So yesterday we did installation. Yesterday and day before yesterday we did installation. So practical part we do everything in Cloudera. Cloudera Quick Start VM. If anyone not install, please install Cloudera or Apache. So ask admin team to get installation videos. Yesterday and day before yesterday videos. They will provide installation videos. So try to install Cloudera or Apache. Then try to practice this HDFS commands. So we install VM Cloudera in VM. So this is our Cloudera Quick Start VM. Cloudera Quick Start VM. Click on this Cloudera Quick Start VM. Cloudera Quick Start VM. No, there is no acknowledgement queue for read flow. Yep. While writing only, it uses acknowledgement queue because Hadoop client has to know whether data successfully writes or not. One important note for HDFS commands. HDFS commands HDFS commands are similar to Linux commands. Linux commands. HDFS commands are similar to Linux commands. What is the difference between HDFS commands and Linux commands? I said both are same, right? Then what is the difference? Linux commands works on single machine. Linux commands works on single machine, right? But HDFS commands are distributed system, distributed commands. So it works on cluster. Yep. Once client get metadata, then it sends request to block 1, block 2, block 3. Nearest mission, sorted order. So this is our Hadoop mission, right? Cloudera Quick Start VM, Hadoop cluster. It may have one or more missions. So in this we installed Cloudera Quick Start VM, Cloudera Quick Start VM, Quick Start VM virtual mission. Assume it may be in remote location. In location. Remote location means don't think remote is in our hands, mission is in different location. Remote means it's different location. Assume. Okay. So this mission, whatever the mission we have, right? Assume this mission is in different location. We have our Windows mission. As a Hadoop developer, we have Windows mission. Windows mission. We want to connect with from this mission to this mission. For that one, we use one software called Putty. Putty is a client tool. Putty. Then through Putty, we connect this mission. So I am explaining how real time we use server missions. So through Putty, we create connection to this mission. So here we enter IP address, username and password. It gives you terminal. It gives you, once it is successful, we will get terminal. Okay, we get what? Terminal. Then in this terminal we write commands. The commands are going to execute in this mission. Okay, so as a developer we are working in our Windows mission. Here if you type any command, that command is going to execute here. Internally for this connection it uses SSH protocol. SSH protocol. SSH means secure cell. Secure cell. It uses SSH protocol to connect this mission. So this mission has IP address, IP maybe example 192.168.0.10 and username. So default Cloudera provides username is Cloudera user, Cloudera, and password, default password is Cloudera. So it has two users, user 1 user 1. User 1 is root, username root, and password Cloudera, and user 2 is Cloudera, password is Cloudera. So by default Cloudera machine has two users. One user is root user, another user is Cloudera user. So we connect through any one user. You can connect either root user or you can connect either Cloudera user. So let's download Putty software. It's simple. I think 10 MB, 10 KB file. Putty download. Some people call Putty. So this one, download Putty. Here you will see first link, download Putty. SSH. Putty is an SSH and Telnet client. Click on this one. Here you will see MSI files. Don't use this one. Use this one. You see 32-bit version, 64-bit version. Click on this one. So it is just simple file. Then we created separate directory for our Hadoop, right? Go to that location. So batch file. Here I am creating softwares. Then what I am doing, I am placing our putty here. I am placing icon into desktop. Placing this icon into desktop. Send it to desktop. So here already we have a shortcut. Let's remove this one. Click on this putty. Click on this putty. Try to make habit of using putty software. We use either putty or putty kind of tools. Either putty or putty kind of other tools. There are other tools also. Those tools are based on putty only. So here we enter IP address or host name. How to find the IP address of our Cloudera mission? Let's open this Cloudera mission and click on terminal. Type ifconfig. It will display. This is our LAN card name. This is IP address of Cloudera mission. Copy this IP address and enter IP address here. Okay, I am giving name to this one, saying name is Qt Cloudera Lab. Qt Cloudera, and click on save. I want to change increase terminal size. So let me, we'll do that one later. Click on open. It will ask login name, username. You can use root user or Cloudera user, Cloudera, and password Cloudera. Okay. So if you want to change settings, so it's showing different font and color, right? Right click here, click on change settings. I'm changing appearances. I'm increasing font size 12 and color. I'm using system color. Okay, it increases font size and changed black to white color. That's it. So here we write a command. If I type ls here, if we are typing command in here, right, but command is executed in this mission, it gives list. Okay, so similar way we write commands here, right? Whatever the commands we write, we can execute commands here. So if you execute commands here, but commands are going to execute in our mission, cluster mission. Okay, so first one, creating files. No, no, no. Same mission, internet connection is not required. If your server mission is in remote location, we need internet. Yep. Yep. Cloudera is in different mission. We need internet connection. Assume our server is located in US. We are working in Hyderabad. So to connect to this mission, they have a IP address, public IP address. They create for every programmer, they create separate username and password. Okay. So using that username and password with IP address, then we connect to that mission. No, same. They create public IP address. IP is very costly. If they create separate IP for different users, it's very difficult because IPv4 is, we have very less IPv4s. Yep, it's very lengthy. IPv6. Yep. Yep, we do everything practice in Putty only, Narayana. Once again, I'm closing and I'm showing. So let's close this one. Close this one. Click on this Putty. Click on run. And here we just created Qt Cloudera, right? Click on load. It enters IP address. Click on open. And one more option I'm doing here. Instead of every time click on changing settings, click on run. Here Qt Hadoop, right? Qt Cloudera, right? Load. And here we have appearance. Change 12. Okay. Change color. Use system color. There is one option called data. Here you can enter common username. So I am entering Cloudera. Okay. Here go to session. Click on save. Click on open. It will directly ask password. Whatever the username we put in data, right? That will take username. Username. Then enter only password of that user. Okay. So clear. Next, creating files. Creating files. In Linux, in Linux, we create files. We create files using cat, touch, t, nano, vi or vim, etc. Here I am using cat command. Cat command. So use cat greater than file1 and write message. Welcome to Hadoop world. Welcome to Hadoop world. Hadoop is big data framework. Hadoop is big data framework. Hadoop has many openings. Okay, in Hadoop Linux we use this one. Let me use cat command. Cat greater than file1 and write message. Control D to save and quit from cat prompt. Cat file1 to display the content of file1. Okay, cat and file name to display the content of file. Cat space file1 to display the content. In Hadoop, in Hadoop, we store files. We store files. We store files. So there is no creation command. There is no file creation command. We store files. File may be from local file system, file may be from FTP connection, file may be from any location. We read that file and we store that file into Hadoop. So we don't have a cat command. We have a storage command. To store file, we have two commands: copy from local, and put command. Copy from local and put command. These two commands are used to copy local file from local file system to HDFS file system. Okay, so syntax for copy from local: Hadoop fs hyphen copy from local, source file and destination. This destination is HDFS path. Let me create my destination location. So let's create your own destination location. So I'm creating destination location using command called Hadoop fs mkdir, and under root I'm creating destination with my name Srinivas. Mostly we create destination directory with required directory name, project required directory name. Okay, so let's go browser and see the IP address. This is IP address of our mission, right? Let's open name node URL :50070 is the name node URL, right? This is utils browse file system. Here it will display all the files and directories presented in our Cloudera or HDFS. So here there is no directory with Srinivas, right? Under root there is no directory. Let's execute command Hadoop fs mkdir. Under root I am creating directory Srinivas. So here let's refresh. So Srinivas directory is created. Under Srinivas directory there are no files. I am going to place file. So by using copy from local, Hadoop fs copy from local, file name is file1, right? File1 under root Srinivas. I am using this command to copy local file from local file system to Hadoop file system. Okay, currently in this directory there are no files, right? Once we execute this command, so here we are giving source file name and destination we are giving just directory name, right? So destination, it will copy this file into destination with the same file name. If you want to save with a different file name, here pass file name, file xyz. If you want to store with a different name, you can use file name. If you not use file name, what will happen? It will create file with this file name. Okay, let's press enter. Let's go browser and refresh. See, file is created, file1. Block size is 128 MB, replication is 1, but actual file size is 79 bytes. Who is created? Cloudera. User Cloudera created this file, and these are different permissions, file permissions. Okay, so to display local file system content, we use command this one, right? Cat file name. To To display HDFS file system data. To display HDFS file system. HDFS file system data. We use command Hadoop fs -cat and root Srinivas. Under Srinivas we have a file1. That's it. This command display the content of HDFS file system. This command display the content of HDFS file system. We are loading only this file into this directory. We are copying our local file1 into Srinivas. Let's create one more file. I am copying cp file1 to file2. So I am copying file2 from local file system to HDFS file system using put command. Hadoop fs -put. Local file name file2, and I want to place this file into Srinivas directory. So it looking both are same. Command syntax is different. Syntax just we are using put here. Previously we used copy from local. Both commands copies local file from local file system to HDFS file system. Okay, so that's it for today, and we'll discuss some more practicals of HDFS file system tomorrow class. Okay, yeah. No, we are copying content of file1 into file2, and we are placing file2 also. Yep. Instead of again creating one more file, then I copied one file, other file content into one more file. Okay. Removal commands we will see tomorrow. Both are same. You can use either copy from local or you can use put. We have two commands. Both commands are for placing local file into HDFS. These commands are Apache Hadoop. It will work on any vendor. Any vendor. These are provided by Apache, not Cloudera. Directly we write in Cloudera. If we enter Cloudera, here we type commands. Yep, we are installing in same location, right? That's what we use putty. No, no, no. We need client tool, Linux client tool. It may be putty, it may be SSH client. Simply we can say command is same. Copy from local or putty is same. There is no difference. It clearly giving we are copying local file, but putty is a universal command. In web development, we use putty to update or copy data. Yep, you can go VMware or you can go Oracle VirtualBox. Okay, so that's it for today. We'll meet tomorrow. We'll discuss some more HDFS commands.